Sinusoidal steady state response of a circuit. Here sinusoidal means input signal, input voltage or input current is sinusoidal in nature or sine wave. Steady state means time is tending towards infinite or all initial conditions are zero. It means there is no impact of initial voltage across capacitor or initial current through inductor in the steady state response of system. In a steady state, we will consider every initial condition as zero. Response means the desired output. Now to find the steady state response of a circuit, we will use Phasor method. In Phasor method, first of all, we will write input signal or input voltage or current, input signal in Phasor form. Phasor form means suppose input voltage is Vm cos omega t plus phi, where omega is input frequency, input signal frequency in radian per second. So in Phasor form, this voltage is V equal to Vm at an angle phi, or voltage V is Vm e to the power j phi. If voltage or current is Vm sine omega t plus theta, then we will write sine in terms of cos, and we know that cos angle minus 90 degree is sine angle. So this is Vm cos omega t plus theta minus 90 degree, and Vm cos omega t plus theta minus 90 degree is Vm sine omega t plus theta. Now in Phasor form, voltage is Vm at an angle theta minus 90 degree, or we can write Vm e to the power j theta minus 90 degree. So that's how we write input signal in Phasor form. After that, we will take the Laplace transform of R, L and C. R is replaced by R. L, Laplace transform of L is Ls, because in steady state we don't consider the initial current or initial voltage. So Laplace transform of L is Ls, and for capacitor Laplace transform is 1 by Cs, where S is j omega, and this omega is input signal frequency in radian per second. Now after taking the Laplace transform of R, L and C, we will apply KVL, KCL or mesh equation or loop equation, nodal equation or voltage divider or current divider to find the desired voltage or current. I am just writing KVL or KCL to find the desired output voltage or current. Now suppose output voltage is say 0.75 at an angle minus 65 degree. Then the output voltage in time domain will be 0.75 cos omega t minus 65 degree, and this will be the desired sinusoidal steady state response of circuit. Now let's see few examples. Sinusoidal voltage source connected in series with 1 ohm resistance, and then one more resistance of 1 ohm connected in parallel with capacitor of 1 farad, and we have to find the steady state voltage across capacitor. Here this input voltage is say 4 cos 2t volts. Now to solve this question of sinusoidal steady state response, first of all we will write the input voltage in Phasor form, and input voltage in Phasor form is 4 at an angle 0 degree volts. Laplace transform of 1 ohm is 1 ohm. For this also it is 1 ohm. For capacitor of 1 farad, Laplace transform is 1 by Cs, and C is 1, so Laplace transform is 1 by S. And voltage across capacitor in Phasor form is Vc. Now for this circuit, see, capacitor and this resistance are connected in parallel, so parallel combination of 1 and 1 by S is 1 into 1 by S over 1 plus 1 by S. So it is 1 by S over S plus 1 by S. So the parallel combination is 1 over S plus 1. Now we can apply voltage divider rule. So Vc is voltage across parallel combination of 1 and 1 by S. So Vc is input voltage. See, the parallel combination of 1 and 1 by S is connected in series with this 1 ohm resistor. So for series combination we can apply voltage divider. Vc is voltage across parallel combination of 1 and 1 by S. So it is 1 over S plus 1 divided by 1 plus 1 over S plus 1. So this one is now 4 at an angle 0 into 1 over S plus 1 divided by S plus 1 over S plus 1. So this Vc is 4 at an angle 0 divided by 2 plus S, where this S is j omega, and omega, we can see this omega input signal frequency is 2. So it is 4 at an angle 0, take 2 common. So this will be 2 at an angle 0 over 1 plus j. This 1 plus j is written in rectangular form, and in polar form it is root 2 at an angle 45 degree. See, a plus jb is r at an angle theta, where r is a square plus b square root over, and the angle theta is tan inverse b by a. So 1 plus j is root 2 at an angle 45 degree in polar form. So this will be root 2 at an angle minus 45. Now this is the voltage across capacitor in Phasor form. Now we will write this voltage in time domain. So this will be root 2 cos omega t, omega is 2 t, and the angle is minus 45 degree volts. So that's how we find the sinusoidal steady state response of circuit. Here I have used voltage divider rule. We could have solved this circuit using KCL also. Let me tell you how to do that. Here voltage at this node is VC. Let us assume that this node is reference node. So now we can apply KCL at VC. So it is basically current leaving must be equal to current entering. So let us assume that this VC is at higher potential. So current will leave from VC to ground. So VC by 1, and then one more current is leaving VC to ground, and that current is VC over 1 by S. And this VC is unknown, so we'll assume that VC is at higher potential, and current will leave from VC to this current source, voltage source, VC minus 4 at an angle 0 over 1. So VC is 1 plus S. This will go to the numerator, and VC by 1. So 1 is there, minus 4 at an angle 0 equal to 0. So VC into 2 plus S is equal to 4 at an angle 0, and this VC is 4 at an angle 0 over 2 plus S, and again S is j omega and omega is 2, so 2 plus j2, this will be 2 at an angle 0 over 1 plus j, and VC is 2 at an angle 0 over root 2 at an angle 45 degree, or in phasor form it is root 2 at an angle of minus 45 degree, and in time domain VCT is root 2 cos 2t minus 45 degree volts. So in this way we can find the sinusoidal steady state response of circuit. Now suppose in the same circuit there is a DC source connected in parallel with the capacitor. What I mean to say, the circuit has a sinusoidal voltage source VIT, that is 4 at 4 cos 2t volts sinusoidal voltage source, and a DC current source connected in parallel with the capacitor. This source is DC. So in this circuit we have two sources. One is sinusoidal source, another is DC source. So now to solve this circuit we can apply superposition theorem. Because this circuit is linear, all the components are linear. In superposition theorem, at a time we'll consider only one source. When we consider voltage source, then we'll make the current source open circuit, and if we make the current source open, then this circuit is same as the previous circuit, and for that input we have already find the output, and the output was, or voltage across capacitor was root 2 cos 2t minus 45 degree. Now we will consider the DC current source only, and when we consider DC current source only, then we will make this voltage source 0. Voltage source 0 means this voltage source is short circuited. voltage source is 0 or short circuit. So this path is short circuited. Now we can see this current source is connected across the capacitor, and we have to find the steady state response. So at steady state, if this capacitor is connected to, steady state means infinite time, if capacitor is connected to this DC current source for a long time, then capacitor becomes open circuit, because capacitor is fully charged and no current will flow through capacitor, and this voltage is Vc infinite. Okay, so this Vc infinite, see, this current source is now connected across the parallel combination of 1 and 1 ohm resistance. So current through this path is I, and both the resistances are equal, so equal amount of current will flow through both 1 ohm resistances. So the current is 2 by 2 or 1 ampere. So Vc infinity is 1 into I, and I is 1. So this is Vc infinity is 1 volt. So total response Vct due to sinusoidal voltage source is Vc1t, and due to DC current source is Vc infinite. So it is root 2 cos 2t minus 45 degree plus 1 volt. So that's how we find the sinusoidal steady state response of a circuit in which we have two sources. One is DC source and another is sinusoidal source. Now let's see one more example in which we have inductor. This is sinusoidal current source connected in parallel with a resistance. One more resistance is there in series with inductor. Current source is IT. This is 1 ohm resistance. This is also 1 ohm, 1 Henry inductor. And we have to find the steady state current through inductor. And this input current source is 4 sine 2 root 3 t ampere. Sinusoidal current source is connected here. Now again we will write this current source in Phasor form, inductor in Phasor form. So in Phasor form, this current, see, this is 4 cos 2 root 3 t minus 90 degree. So in Phasor form, it is 4 at an angle minus 90 degree ampere. And for resistance remains unchanged. For inductor, Laplace transform of inductor is Ls, L is 1, so it is S. And current through inductor is IL. Now we can apply current divider rule to find IL. This IL is current source 4 at an angle minus 90 degree into this 1 ohm resistance over 1 plus this series combination of 1 plus S, series combination of 1 and S, that is 1 plus S. So it is 4 at an angle minus 90 degree over 2 plus S, where S is j omega and omega is 2 root 3. So this IL is 4 at an angle minus 90 degree over 2 plus j 2 root 3. So it is 4 at an angle minus 90 degree. Take 2 common. So it is now 1 plus j root 3. So it is 2 at an angle minus 90 degree over 1 plus j root 3. And 1 plus j root 3 is in rectangular form. In polar form it is, in polar form this will be square root of 4, that is 2 at an angle tan inverse of root 3, which is 60 degree. So it is 1 at an angle minus 150 degree. And see, this current is in phasor form. In time domain, this current will be 1 cos omega 2 root 3 t minus 150 degree, or this can also be written as sine 2 root 3 t at an angle minus 60 degree. So that's how we find the sinusoidal steady state response of a circuit.